All right, let's look at solving quadratic equations. When it's an equation, it's got an equal sign on it. That's what makes it an equation and not an expression. When it is a quadratic, what we're going to do and what we're looking for is where the graph crosses the x-axis. A quadratic equation graph is going to look something like this. It's a parabola. We'll get into this a little bit more later on, but this is a parabola, and it'll either be this way or it'll be that way. And what we're looking for is where it crosses the x-axis. In other words, when is y equal to 0? That's what we're looking for. We'll typically get two answers. Sometimes you'll get one that will just kiss the x-axis, and there's only one answer. And sometimes it doesn't even touch the x-axis at all, and you get an imaginary answer, and we'll get to those later. But you can get one answer, you'll get the same answer twice. Like this arm comes down, the left arm comes down and touches once. The right arm comes down and touches once, so you get the same answer twice. Or both arms break through, and you get two different answers. Sometimes positive, negative. Sometimes if it's moved way to the right, both positive. Sometimes if it's moved way to the left, both negative. The main thing is when y is 0. So the way we're going to solve a quadratic equation is we're going to get it set equal to 0, so that where that y would be, it would normally be ax squared plus bx, plus bx plus c equals y, or the y equals is on the other side. Either way, it doesn't matter. But what we're going to do is we're going to place that with 0. So if the equation is already set up and we've got stuff on both sides, we're going to get everything to one side, get 0 on the other. And when we do this, factoring sets up a very easy way for us to be able to solve a quadratic equation because of the zero product property. Product, remember, means multiply, so it's the zero multiply property. So here's what we're saying. If two expressions, if the product, the multiply of two expressions is 0, then one or both of the expressions equals 0. And here it is in letters. If a and b are both expressions, so when you do a times b and it equals 0, then either a equals 0 or b equals 0 or both equal 0. So that's how we're going to solve a quadratic. For me, it's one of the easiest ways to solve a quadratic is if it is factorable. You can factor it out, and each factor's got to make itself turn into 0. That's what x's are needed. So let's look at a couple of examples. Here we have 2x squared minus 5x minus 18 equals 0. Step 1 is get it set equal to 0. Well, luckily enough, it already says equals 0. So now all I have to do is factor it. Remember, always, every time, the first time, look for the greatest common factor. 2, 5, and 18. Well, 2 goes into 2 and 18, but not 5, so no greatest common factor. So we're on slide and divide. A is positive, so we're ready to go. Slide to the back. X squared minus 5x minus 36 equals 0. Do your factoring. Notice I bring down the z equals 0 every time. Don't forget. Each one gets an x. Factor the 36 at subtract to 5. Well, the first one's off in my brain for 36 are 9 and 4. 9 minus 4 is 5, so 9, 4. Big number gets the middle sign. The other one gets the opposite. If you slide it, you got to divide it. So x minus 9 over 2, because that doesn't reduce, and x plus 2, because that does reduce. Now, normally we would take this little 2 and we slide it right in front, and that would be our factors. But when I'm solving, I don't actually make them the true whole number factors, because it saves me a step when I solve. Because what I'm going to do is I want this parenthesis to turn into 0, and I want this parenthesis to turn into 0. So I want to know what numbers of x make that happen. So I'm just going to take each one individually and set it equal to 0. And then solve. Now all I have to do is add 9 halves over instead of add 9 divided by 2. Just saves me a step. So x equals 9 halves, or 4 1/2, 4.5, or however you want to talk about it, but that's one of my answers. This side, I subtract 2 from both sides, get x by itself. X is negative 2. There's my other answer. I get 2 spots. And that's what I'm looking for. Now, if we switch to the blue problem, we got 14x squared minus 2 equals negative 3x. This time, it doesn't equal 0. So, move your 3x so it's not on that side. This side turns into 0, and over here I've got 14x squared. I should put the 3x in the middle. The linear term always goes in the middle. Constant at the back, squared at the front. And then I'm going to factor. Step 1, greatest common factor, 14, 3, and 2. Well, 14 and 2 have a common thing, but the 3 ruins that, so we're just going to, a is positive, so we'll slide and divide. Multiply by 14, x squared plus 3x minus 28 equals 0. Factor. Each one gets an x. And factor to 28, let's subtract to 3. 28 right off the head is 4 times 7. And 7 minus 4 is a 3. If you slide it, you got to divide it. So that's x plus 7 goes into both 2. Nope. Not 2 times into 7. 1 time into 7. 2 times into 14. And 2 goes into both. That'd be 2 and 7. Now, normally I'd move that 2 in front of the x and move that 7 in front of the x, but because we're solving, I'm going to skip that spot and just go straight to solving. Now, if you notice, back over here in the red, it was 9 halves and it's 9 halves. The difference being that it used to be plus and now, or minus, and now it's plus. It was a 2 and now it's a 2. The difference, it was a plus and now it's a minus. So when you're trapped in these parentheses and you pull this number out of there, you do the opposite. I kind of think of it as if you're going to hop out of the parentheses, you got to be the opposite. So I take the opposite whenever you come out of there. So if we apply that over here, x has to be 2 things. It needs to be change the sign to negative and bring out the 1/2, opposite out. Change the sign to positive and bring out the 2/7, opposite to get out. Boom, there's our answers. And that's how you solve a quadratic.